In our last video, we showed how we built a battery bank that would sustain a food truck for up to 4 hours. In less than a week, we realized that the startup and shutdown procedures were far too complicated to be repeatable, and the solution for this would probably be an automatic transfer switch. We also wanted to address the potential for power surges like the one that we experienced that destroyed our refrigerator last year. We found this Ames inverter charger transfer switch and surge protector combo would be the most cost-effective way of managing all of these issues at once. But it's just a little bit bigger than the box that we have, which means there are going to be some heavy modifications necessary to get this into the truck. Again, I'm going to use cardboard to get a feel for how the inverter will fit in the truck, and then begin building the box with wood. The first thing I wanted to build was the base that would hold the inverter to the wall. This needs to be tough enough to handle the bumps in the road, along with hard stops, and also it needs to be a good barrier against electricity. I'm using a larger drill bit to enlarge the holes so that the hex bolts will sit flush against the wall in the truck. This part of the job really sucked because this inverter weighs over 70 pounds and I'm holding it at a really weird angle. This probably should have been a two-person job. Once it was up on the wall, I was pretty happy with the results, so I moved on to the cooling system. The instructions that came with the inverter specifically said that it should not be put in a box. That's exactly what I'm going to do, so I need to make sure that I have enough airflow to keep the inverter cool while it's inside the box. According to the instructions, the fan for the inverter moves air at 140 cubic feet per minute. Just to be sure, I'm installing a fan that moves 200 cubic feet per minute. And to be doubly sure, I'm going to install a second one, so that will be 400 cubic feet per minute flowing through the box. Once I had all the pieces cut to size, I roughed it together in the truck to make sure that everything was going to fit properly. Now that I knew the pieces were going to fit, I took it apart and spray painted it using black Plasti-Dip. While the paint was drying, I decided to start the wiring of the inverter. It's extremely important to notice that I consistently cover the cables with electrical tape whenever I am not directly installing them or securing them to the inverter, and this is for safety's sake. You start by installing the negative terminal according to the instructions that Ames provided, and when you install the positive terminal, they warn that there will be a small spark. That was nowhere near as bad as I thought it was going to be, but I'm certain it probably would have been pretty scary to me if I didn't know that that was coming, so I appreciate that they had that in the instructions. As an added feature, our inverter charger comes with a temperature sensor, which I just installed in the batteries, and I'm now starting the wiring from the inverter to the breaker box that distributes the power to all the equipment in the truck. You might notice that the neutral wire that I'm using is red instead of white, and that's only because I didn't have 8-gauge white wire on hand, but I'll later add some blue electrical tape to get it up to code. The generator and the shore power that we use to recharge the truck are both 240 volt, but the inverter is a 120 volt. So to solve this, I'm wiring this as a standard breaker box, and I'm only going to wind up using one of the hot leads off of this, which will effectively give us a 120 volt circuit. Now that we have power coming in from the generator or the wall to recharge everything, the only thing left to do is to wire that into the input of the inverter. And you'll again notice the weird red wire with the blue tape on it to indicate a neutral wire. With everything wired up in the truck, it was time for a test, so I plugged the truck in and threw the main breaker on. Nothing blew up, so I threw the inverter switch on and it went into battery charging mode as expected. By the time I was done wiring everything up and testing it, the paint on the box was dry, so it was time to put the finishing touches on that. And I began with wiring up the fans and then reassembling the box. The cover that fits behind the driver's seat has been cut more times than anything I've ever worked on in my life. And once again, I am modifying it so that it will accommodate the box that we just built for the inverter. I also needed to drastically enlarge the hole that I cut for the intake pipe so that we could bring clean air in from the outside. A few finishing touches on the paint job, and we were good to go. A process that once involved flipping of multiple breakers in a certain sequence now just required you to pull the plug and drive away. Alright, so we talked about what happens when you get back. So when you get back, now all you have to do I hate these plugs. First world problems here, boys. Plug her in. Here's the best part. All those lights are still on. They've been on since I got back. And it's sensing that light's gonna turn green. And you can go home now. In our next video, we're going to extend battery life and solve premature shutdowns using ultracapacitors. If you'd like to see more videos like this, please subscribe. Thank you.